In this video, we're going to carry out calculations based on the chemical formulas of substances, and in particular, we're going to look at calculating the mass percentage of each element in a compound. A typical problem you might get along these lines is shown here. What is the percentage mass of the elements hydrogen and oxygen in the compound water? We can express the mass percent composition of an element A in a compound as the mass percent of element A equals the mass of element A in a sample of the compound divided by the total mass of the entire compound in that sample. And we multiply that ratio by 100% to turn it into a percentage. So if we are talking about the compound water, we know that we can calculate the mass of 1 mole of water by calculating the molar mass. And we do that by summing up the molar masses of all the atoms in the molecule, which is 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. Reading the atomic masses, or the molar masses, from the periodic table gives us 2 times 1.008 grams per mole plus 1 times 16.00 grams per mole, which comes to 18.02 grams per mole for the molar mass of water when we restrict our answer to 4 significant figures. And we also know that this therefore means that the mass of 1 mole of water is 18.02 grams. The mass contribution from just the hydrogen atoms in 1 mole of water is given by this value here, 2 times 1.008 grams, and we can substitute this value into our mass percentage equation, giving us 2 times 1.008 grams divided by 18.02 grams multiplied by 100%. Now just remember that this number here comes directly from the periodic table, 1.008, the mass of 1 mole of hydrogen expressed to 4 significant figures. And this number here, 18.02, is the mass of 1 mole of the entire compound. When we plug these numbers into our calculator, we get 11.19% being the mass percentage of hydrogen in water. The mass contribution from just the oxygen atoms in 1 mole of water is given by this value here, 1 times 16.00 grams. And again, we can substitute this value into our mass percentage equation, giving us 1 times 16.00 grams divided by 18.02 grams multiplied by 100%. And again, we see that this number here is derived from the periodic table, the mass of 1 mole of oxygen rounded to 4 significant figures. And this number here is the mass of 1 mole of the entire compound. And when we plug those numbers into our calculator, we get the value 88.79%. So the mass percentage of hydrogen in water is 11.19%, and the mass percentage of oxygen in water is 88.79%. And that's interesting because there are actually 2 hydrogen atoms for every 1 oxygen atom, and yet the mass percentage of oxygen is so much higher than hydrogen. And of course, that's because the mass of an oxygen atom is about 16 times more massive than the mass of a hydrogen atom. When we add these 2 numbers together, we get a total of 99.98%. So a good question to ask is, why isn't it exactly 100%? And the answer lies in some errors that were introduced in the process, particularly some rounding errors owing to the fact that we rounded all our calculations to 4 significant figures. And we've also got to remember that what we're dealing with here are measurements. So the reported numbers for atomic masses and molar masses are actually measurements, and we know that they are subject to limited accuracy and limited precision. Let's have a look at another example here, this time for an ionic compound. What is the mass percentage of each element in the compound calcium carbonate, CaCO3? We can calculate the molar mass of calcium carbonate by recognizing that we sum the molar masses of each atom in the formula unit. 1 times the molar mass of calcium plus 1 times the molar mass of carbon plus 3 times the molar mass of oxygen, giving a molar mass of 100.09 grams per mole. And again, we recognize that if the molar mass of calcium carbonate is 100.09 grams per mole, then the mass of 1 mole of calcium carbonate is 100.09 grams. We now note that the mass contribution from just the calcium to 1 mole of calcium carbonate is 1 times 40.0 grams. and the contribution from just carbon is 1 times 12.01 grams, and the contribution from just oxygen is 3 times 16.00 grams. We can substitute all these values into our mass percentage equation, starting with the mass percentage of calcium, which equals 1 times 40.08 grams divided by 100.09 grams multiplied by 100%. Remembering that this number here we get from the periodic table for calcium, representing the mass of 1 mole of calcium. And this number here is the mass of the mole of the entire compound. And when we plug these numbers into our calculator, we get the number 40.04%. We can do the same for carbon. The mass percent of carbon is the mass of carbon divided by the total mass of the compound. The contribution from carbon being 1 times 12.01 grams divided by the total mass, 100.09 grams. Remembering again that this value here comes from the periodic table for carbon, representing the mass of 1 mole of carbon, and that this is the mass of 1 mole of the entire compound. When we plug those numbers into our calculator, we get 12.00% as the mass percentage for carbon. The mass percent for oxygen is the mass of oxygen over the total mass of the compound. The contribution from oxygen is 3 times 16.00 grams. Remember, we get this number from the periodic table for oxygen to 4 significant figures, representing the mass of 1 mole of oxygen. And this number here again is the mass of 1 mole of the entire compound. When we plug those values into our calculator, we get the number 47.96%. So we've got mass percentages for calcium, carbon and oxygen being 40.08%, 12.00% and 47.96% respectively, which comes to a total of 100%.